Intelisum's process for capturing an as-is LD3 dataset for a capital asset. The process to capture an as-is life-dimensional 3D dataset for a capital asset combines two well-proven practices. First, the practice of dimensional survey control, and second, the practice of scanning the site with a high-density laser scanner. The dimensional survey control will be used to tie the scan data to a specific coordinate system. This process requires the following 9 steps. Step 1. The scan plan is created by the scan team during a walkthrough of the proposed scan site. At this time, scan locations are noted on the drawing of the site. Possible locations for control points are also planned. Step 2. A qualified survey technician will set up the baseline control for the project using a high-precision instrument called a total station. In some situations, a high-precision GPS station will be used along with the total station. Step 3. Once the baseline is set, the surveyor will create control points for the project. These points are known points that the surveyor will use to move his instrument to ensure that all the scanned targets are captured. Step 4. During scanning, targets are placed in the view of the scanner. Each target has a number associated with it. The number identifies the target to the scan operator and the surveyor. These targets are surveyed in using a total station. Step 5. The targets are captured by the surveyor from many locations. Each target is acquired from several locations, giving redundancy and accuracy to the data. Step 6. The scan operators make sure they have captured each of the targets in the scan as well as in the survey. A recommended minimum of 5 targets is needed to ensure good registration. Step 7. Once each scan has completed, the scanner operator loads the scans into the ld3 software and extracts the targets. The user names the target according to the number on the target. These extracted targets are called tie points. They will be used to tie the survey and the scans together. Step 8. After scanning and surveying is completed, the operator imports the scan data into the ld3 Studio software. The survey data is shown using cones and has a target number for its name. Step 9. Each scan is then imported into the ld3 software. On import, the scans and the tie points are visible on screen. Using the ld3 registration tool, the user selects Register, and the software links the tie points and the survey together using the target numbers and calculates a fit using registration algorithms. The software then shows the user a registration error report. This report tells the user how accurately the data is registered to the survey. The end result of the scanning and registration process is an ld3 dataset that is accurate and geolocated to your coordinate system. This dataset is now ready to be used in other workflows, such as the renovation workflow. Exporting scanned data into an ld3 modeling package is a simple process. Inside the ld3 software, the user clicks on the selection tool to select a section of the data to be modeled. A rectangular selection tool or a polygon selection tool is used to select the data. It is important to remember that the scan data is in 3 dimensions. This means the user will add to and subtract from the selection using different points of view. Once the appropriate data is selected, it is then exported to a 3D file format. ld3 Studio exports many different file formats, supporting most 3D design and CAD softwares. To export the data to a format used by Revit, we will export to the DWG format. A dialog box gives the options for exporting to DWG. After a file name is given and the appropriate options are selected, the data is exported. Now the file can be imported into Revit. The file is imported using the CAD import option in the system. This file is placed geospatially in Revit based on the chosen coordinate system from ld3. Once the file is imported, it is used as a template to model the as-is data. Additionally, all of the BIM information is added to the model. After the data is modeled, it is time to bring the model back into ld3 for verification. First, the ld3 template data is removed from Revit. Second, the model data is exported in IFC format using the export tools in Revit. When the file is exported, it is brought back into ld3 Studio using the IFC import tool. The file is chosen from the dialog box, and the system imports and places the file in the correct location. Now we can view the model in the as-is ld3 data, verifying if all the information was modeled correctly. The added BIM information is also available and can be viewed in ld3 Studio. This process repeats, selecting additional data and modeling until the necessary data has been modeled. There are three main workflows used when a renovation is undertaken using ld3 Studio. First, importing the renovation data into ld3 and checking for clashes and making necessary changes. Second, exporting ld3 scan data into a design package and designing around the scan data. Third, modeling all of the scan data and creating the renovation design using the modeled data. All three processes are simple and effective. The choice of which to use depends upon time, costs, and abilities of the design group. The first workflow assumes you have relatively good documentation on your as-built. The design is created using the existing building information and then imported into ld3 Studio to verify that the design is accurate. If any clashes are found, the user will model or export the scan data in the clash areas and update the design to mitigate any issues. The second workflow assumes that there will be issues in the existing design and exports data in the corridor that the new design will be placed. In this case, the designer uses the exported scan data as a reference, designing around the data and eliminating conflicts during the design process. The final workflow assumes that an accurate as-built will be created from the scan data using modeling techniques. This process creates an accurate CAD file that the designer can use to create the renovation design.